doubt on arithmetic, integer arithmetic operation. Okay.
Yes, ma'am.
Yeah, but why this is not showing up? Yeah. So if you see that integer arithmetic operation, why I'm saying, because there is also something which I haven't discussed yet, but and also I'll not be discussing in details, which is floating point number. Okay, so there is a whatever we were discussing so far were fixed point numbers. Okay, fixed point numbers, but there is something called floating point numbers also. You have also seen that in your C programming. There is a data type called float. Okay, and with that float you initialize values, and the operations based on floating point operation takes place. The idea here is that these are integer arithmetic operation. What are arithmetic operation? We have learned about arithmetic operation in our course in digital electronics. So add, sub, mul, div are the important operation, and then you can have remainder and absolute and all those things, negate, etc. So these are nothing but some kind of instructions that are operated on your data. So here you see add u is basically an instruction which add the content of two registers. There are two source registers and it stores the value in destination register. So something like, let's say, add R1, R2, R3 is this instruction. Okay. Similarly, sub, it is like this. It will store in the destination register what? If it is sub R1, R2, R3, then R1 will be equals to R2 minus R3. Okay? And so on. There is something to look into. What is mul? This thing. Okay. Mul, this thing is for immediate some source or immediate value also you can provide. And this MULT is for multiplication of two numbers where there is high-low. You remember, if you multiply two n-bit number, what will be the result? Final result will be how many bits?
2n.
So you cannot represent that in 32-bit, right?
Yes, ma'am.
So that is why you require more number of bits, right? That is why both for multiplication and division, you require high-low. Getting it?
Yes, ma'am.
Yeah. So the best way of understanding each of these instructions is by executing this using the simulator and see what result it is coming and how it is getting executed. Clear?
Yes, ma'am. Yes,
Yeah.
ma'am.
Yeah. So any specific doubt that you had from here?
No, ma'am. Actually, this chart only I was not getting that nicely. Actually,
Okay. So this is
this was
nothing but
like I was stuck. Then I rewind. I replayed it, but still, like I wasn't getting clear.
yeah.
That's why.
Yeah. So these are nothing but some set of instructions. Okay. So these
Yes, ma'am.
instructions are already inbuilt in your MIPS architecture, and you can use this in your programs when you write something. When you want to execute something, you can use these set of
Like
instructions.
predefined functions or something like that.
These are already inbuilt. That what is adder? You remember in an adder you
Mm-hmm.
have to add, let's say, 2 n-bit number. If you have to add, you need to have the hardware for it.
Yes, ma'am.
And specifically, there will be some instructions, okay, that you will provide it to the computer so that the computer can execute that instruction, right? So The name add is basically one of those instructions for which the hardware is available. Okay, sub is a kind of instruction for which the hardware is available, and you can use this for executing an instruction. You remember in C language, you do this, right? Hash include stdio.h. What is this?
Header
What is
file, ma'am.
this? Is a header file, right? This
Yes, ma'am.
header file contains what? Have you seen what is there in stdio.h?
There are some
Yes,
set
ma'am.
of
A lot
instructions
many
to perform all
File.
the
instructions, a lot
A
many
lot of
to perform all the
functions,
code.
basically. You call it
functions. Yes,
functions,
ma'am. A lot of functions.
right? You can say
Yes,
those
ma'am.
are instructions. Everything boils down to instructions only. But those are nothing but
This is a
some kind of
yes, ma'am.
functions,
Functions.
right? One function is
Not a
printf,
function.
another function is scanf, and there are many other functions. I'm giving you two representative
Scanning.
functions, printf and scanf. You recall what printf does? What printf does?
It prints something.
It gets
Print something where
It give us
The
output
data which
output
in display.
printed.
In the monitor.
in the display, in the
Yes,
monitor.
ma'am. In the
You get
display.
the display in the monitor, right? You get the display in the monitor. So
Notice.
basically, printf function instruct the computer, and basically this information is nothing but the information is passed to something called kernel, which executes a set of code to inform the display unit that you need to display this particular text, whatever text you have written. So these are the following steps that are required, and in this process you will see there is something called system call that comes into picture. Have you heard of it?
Yes, ma'am. That was the part where you told about that MIPS instruction encoding and everything.
Yeah. So basically, this you try to understand it using your C program. When you write a C program, the functions, the inbuilt functions like printf and scanf, which you use, they typically involve some hardware involvement. What is that hardware? The hardware is this function actually outputs certain things in your screen. And your screen is nothing but your monitor, okay, which is a hardware device. So there must be some communication between the operating system. The operating system is what your basic interfacing unit between the user and the hardware of your computer. How does we, the user and the hardware, communicate? We communicate through some set of softwares, which is called operating system. Your Windows is an operating system. Your Ubuntu, your Linux is an operating system. Okay. So whenever user wants to interface or connect with the hardware of the computer, it has to be with some intermediate programs. We call it operating system. Okay, you have a full course on operating system in your, I think, 5th semester. But as of now, you understand that anytime a user wants to interact with the hardware, your monitor is a hardware, right? Now think of scanf. What do you do in scanf?
Can I hold some value, read the data from keyboard and
Read the
hold.
data from keyboard, right? It reads the data from keyboard. So keyboard is again a hardware. Okay. So when you read a data from the hardware, again you need some kind of function or some kind of system call to read the value from this device and then to store it in your computer in some location that you have specified. That's why when you do scanf, what do we do? Percentage D ampersand A, right? And then let's say, so sorry. So if it is int A, then scanf ampersand A we do to get the value, right? So that ampersand A is nothing but the address of that value that we take generally, right? So for interacting with the hardware of your computer, you basically need some system calls, okay? And what are these instructions? These are certain instructions which are available to the user. We are not seeing the system call exactly here, but these are the functions which are in that architecture. The architecture, that is MIPS, supports these instructions. Okay, that means all these instructions could be executed using your architecture. Is that clear? Yeah, is this clear to all of you?
Yes, ma'am.
Yeah, let's move on to logical operations. These are logical operations. So these are nothing but set of instructions. Now I'm telling you that if you have to execute or write a program, you need to know different kinds of instructions that your computer can support, right? So these are some of the instruction, and, nor, you know.
Ma'am.
What is the, yeah.
Ma'am, can I say something? Actually, I have executed that example that one program.
Yeah.
Can you say that is right or not? Actually, I'm not getting
Okay,
that.
I will see that. I will come to that. Let me discuss very briefly on this. So
Okay,
logical
ma'am.
operation is fine with all of you? Shift operation is
Yes,
also
ma'am.
fine with all of you?
Yes,
Yeah.
ma'am.
So control operation is something you have to know about this, but this is something more. So I will be discussing this maybe in your next semester. But for now, you understand that jump means you think of any program. So any program is nothing but for a loop. What do? For I equals to 0, I less than 10, I plus plus. What will happen if you write sum equals to sum plus a of I? So basically, repeatedly from an array, if there are 10 elements, 1, 2, up to 10, so it will add this 10 values, right? So this is something which needs to be done repeatedly. So after it comes here, it again should go there. Some condition needs to be checked and again it goes here. So we need some kind of control statement. Jump is one of them. Yeah, let's move on. Conditional statement. Now, can you see the screen, all of you? Have you opened your PC?
Yes, ma'am.
Yeah. Okay. Now,
Hmm.
Trishita, you were asking, right?
No, ma'am.
Trishita? Yes.
Yes, ma'am.
Upamita was asking.
Promita was
No,
asking, ma'am.
ma'am.
I'm not.
Upamita.
Yes, ma'am.
Yes,
Upamita was
ma'am.
asking.
Upamita. So, which program you have gone? Have you all
1 second,
understood
ma'am.
this part?
No,
This part of
ma'am.
the...
Ma'am, this was one of the part that I told that.
Yes, yes. So let me discuss this and then I'll come to you, Upamita. Is that okay?
Yes, ma'am.
Okay. So
Ma'am,
all of
ma'am,
you must understand this.
that example program one I have executed.
Okay, good, good. I'll see that. Okay. Give me
Okay,
2
ma'am.
minutes. Let me explain this and then I will tell you. Yeah.
Mm-hmm.
So this operating system interface I was talking about, this is syscall, system call. Now you tell me that how will the computer understand that whether you want to accept an integer or you want to accept a string or a character, etc. Okay. So, and what do you want to print? Whether you want to print an integer or you want to print a string. So for both of these things, in MIPS architecture, these are the codes that needs to be put in certain register. This register is called V0, and there are certain registers called A0 and A1, where you have to put certain values for printing. Okay, it is so you can see a difference here. The way when you wrote a program in C. What is C language? C language is a high level language, right? C was the language which is a higher level language.
Yes,
so you just had to do int I, initialize with 0. So in the memory, somewhere in some location, I will be initialized with 0. Okay, and I has got an address. You write a printf and something gets printed there. You write a scanf, you get printed there. But within the function printf and within the function scanf, you as an user is not bothered what is there. But inside this, there is some system call which says that you are printing. That is what percentage %d for integer, percentage %f is used for something else, and many others, right? So these are the directives that are there for which you will understand that how will you print an integer, how will you print a string, etc., etc. Similarly, in MIPS, this is how it is done. If you want to print an integer on the screen, okay, so let's say you have a value which you have initialized with .word sum .word type, some value you have initialized to this. Now you want to print that value. So for printing that value, what you need to do, you need to do this thing. In $A, you have to initialize the integer, and the code you have to put in V0 register 1, and then only it will print. Okay, so there are certain instructions to do that, using which you can load 1 in V0. We will look into that. But for now, you understand that for the computer, the MIPS instructions and the MIPS architecture is based on the concept where you have to specifically say that when you want to print an integer, then certain things you have to do it. If you want to print a string, you need to do certain things. What is that certain thing? You need to initialize the particular register with certain value, a particular register with that value. So this you have to remember. These are the codes for printing integer, printing string, or you want to read integer from keyboard. Then you have to do this, and you want to read string from keyboard. You need to have this in $V0. $V0 is a register, okay, where 1, 4, 5, and 8 and 10 needs to be kept, okay, for performing these things, for printing an integer, printing a string, printing an integer, printing a reading a string, or exit. One is for exit. Okay. And apart from that, what value should have in A0? Basically the argument, the integer that you want to print. Okay. Or here, the address of the string. You know the concept of string in C. You have done C, right? So the concept of string, you already know. Basically, if this is a string with apple, A-P-P-L-E, if this is apple, it is \0, right? Okay, yes, so this is the string. The first address will be, if you see the first address, if it is 2000, okay, each character is 1 byte. Isn't it? Each character is 1 byte. So 2000, this will be 2001. This will be 2002. Byte addressable, right? Each byte has got one address, and so on, right? So similarly, Here you have to provide address of the string. So first address, let's say it will be 2000. And after from read integer, the value will be available in V0. Similarly, here for reading the string, the address of the string will be available in A0 and the length will be available in A1. So guys, let's do it and let's understand it rather than discussing it further. Okay? Is it clear, guys?
Yes, ma'am, it's
Yes,
better.
ma'am.
We have to do in our hand, otherwise we can't understand.
Exactly. Let's do that. Okay. Now this is very important. This you have to understand. Now remember, when I was discussing about instruction encoding, I never told that there will be something separate for, R type means register type, I type means immediate type, and J type means jump type instruction. Okay, so this is typical of MIPS instruction encoding. Again, as I said, guys, with this limited time, we are very quickly going through all these things, but we will be seeing the entire MIPS architecture in your next semester. Okay. So for now, you just understand this because this will help you for instruction encoding, right? So here it says that this is how it's a 32-bit instruction. 32-bit instruction is like this. There is an opcode bit. There is a source. RS is one of the source. RT is another source. RD is one of the destination. This is a shift value. Okay, we don't have to understand why it is required at this point of time, but you say that this is fixed. Okay, if your instruction does not require a shift value, this will be 0. Okay. And this is a function value. So in MIPS, there is an opcode extension that takes place. This is an opcode. You know what is an opcode? For add, there will be an opcode. For mul, there will be an opcode. But again, and there is an extension. If this opcode can have a variety of 5 things. Okay, let's say if it is 00000, then basically these are all logical operations. And if it is logical or, something will be there for this function. If it is logical and, then some other value is in funct function. Okay, again guys, you just remember this format. We will see with one example. Okay, and then you will understand it better. Okay, so let's move on. First example. Instead of doing this example, Upamita, I'll tell you first to do this. Can you all see my screen, right?
Yes, ma'am.
Yeah, please open this QtSPIM.
Yes, ma'am.
Okay, prior going to this, I have to tell you one more concept, which is very, very important, guys. Before that, I cannot move. So this is what I wanted to discuss. I told you something called byte ordering, but I said that I'll be discussing in the lab, right? So how are actually bytes stored? So let's say your name. Let's say Ramu. Let's say a name. Name is Ramu. Okay. So sometime back, I've sent you a link there. Have you seen the ASCII code? And its equivalent representation in hexadecimal? Yes, guys?
Yes, ma'am.
Yeah. So please look into that. Okay. Because that will be essential for your mapping. Now we are understanding that how your data is stored in memory. You already know that what is a memory, but you must know that how a character is stored, how an integer is stored, how a long integer is stored, how floating point and double precision numbers are stored. They are stored like this. A character takes 1 byte. Okay. An integer takes 4 byte in the memory. A long integer takes 8 byte. A floating point takes 4 byte. And double precision takes 8 byte. Now there are different computers uses different data ordering convention. Data ordering convention means, okay, if you say this 01101, this is the least significant bit, LSB. As you move on, this is the MSB. Agreed, all of you?
Yes, ma'am.
Least significant
Yes, ma'am.
bit and significant bit. Now, there are conventions. As our computers are byte addressable, there are two ways through which these values are stored in memory. One is low order byte first. Understand this, low order byte first. Low order means this value will be first. Then this value, and so on. So basically, if this is 1 byte, this is next byte, this is byte 1, this is byte 2, this is byte 3, and this is byte 4, lower order byte first. That means this byte will be stored in the first location. If your memory location starts from 2000, so B1 will be stored at 2000, B2 will be stored at 2001. These are single byte, okay? 2002, B3 will be stored, and 2004, B4 will be stored. Okay? We'll take some examples to understand this. So, the other one is high order byte first. These are the two ways. High order byte first means B4 will be first. So, in 2000 location, B4 will be there. Then 2001, B3 will be there, and so on. Let's see this. For a 16-bit number, this and this, you see? So there are two ways. One way is just this will be stored in the first location, then this byte. Another way is first this byte is stored here, and then this byte is stored here. These are the two ways of storing it. Is this clear, guys?
Yes,
Not
ma'am.
clear, right?
Yes, ma'am. Not that
Yeah.
much. Like,
So
we
can
just
you
understood.
read this sentence? Little endian. There are two conventions. Okay. So we will concentrate on little endian, but these are the questions which generally comes in your gate as well. Little endian and big endian. Okay. Little endian means least significant byte is stored at lower address followed by most significant byte. Example, in Intel, they follow little endian. D, C alpha, these are the major processor manufacturer. They use this little endian way of storing. Please remember this. Least significant byte is stored at lower address, followed by most significant byte. And big endian is most significant byte is stored at lower address, followed by least significant byte. Let us see with example, then only it will be clear. Now see. This is a 32-bit word. Okay, each is 1 byte. This is the, what is this one? This is the least significant byte or not?
Yes, ma'am.
Least significant byte. Then the next byte. So we can consider this as B1, this as B2, this as B3, and this as B4. This is the least significant byte and this is the most significant byte. Agree, all of you?
Yes, ma'am.
Okay. Now you see, little endian means least significant byte is stored at lower memory address. Is it happening?
Yes, ma'am, it is happening.
All of you?
Yes, ma'am.
This is the least significant byte. You see, first it is stored in the first memory location, which is 2000. The next one is stored at next higher location. The next one is stored at next higher location. And the last one is stored, most significant bytes is stored at the last location. And so on. So this is basically little Indian way of storing the data in there. So if it is A, B, C and D, tell me where D will be. All are 8 bit, let's say. A, B, C, D. Where D will be stored? Where D will
In
be
the
stored?
2000 location,
At location?
the first one, 2000 location,
2000. C will be stored in the next location.
2001.
Yeah. D will be stored here. And A will be stored here. Fine? So
Yes, ma'am.
132-bit word, it will be stored like this. Now you tell me big Indian.
It will be A, B, C, D, like
Yeah,
A
it will
The
be
A1000.
opposite
A,
one.
B, C and D. If it is stored at A, B, C, D, which is the most significant byte? A?
A.
A is the most which will be stored in the lower memory address. Okay. B will be next, C will be next and D will be next. Agreed?
Yes, ma'am.
And for this one, it will be first D, then C, then B, then
B,
A.
then A.
Agreed?
Yes, ma'am.
Okay. This you have
Yes,
to
ma'am.
remember. Okay? Please remember this. Now, let's move on with the real programs. So this screen is open for all of you?
Yes, ma'am.
Okay. So we'll see the text first.
Yes, ma'am.
Okay, we'll see the text first. First of all, you have you written a program and saved it?
No, ma'am. I
Right?
haven't written anything.
Yeah, please do that. Create a folder as ASM programs like this. Create a file, test add with the extension ASM file. Okay. .asm and let me know.
Ma'am, can you please repeat?
I'm sharing this file with you guys. That will be the best thing. Yes?
Ma'am, what will be the file's name? Like,
So you can just give a test add anything, any name you can give. So I've posted a file in your Google Classroom. Can you see that? So the first thing first you have to do is create a file called test add or whatever. Okay. So this is a sample file. Okay. So for the sample file, so we do not have any data section for this particular program, but you see we have the text section. In the text section, you can write .text, .global main, and main colon is where your program starts. Okay. All of you are with me?
Ma'am, just making the file.
Yeah. What about others who have already made the file?
Didi বন্ধ কর ম্যাম মি
Upamita, you have made, right?
Yes,
Have you
ma'am.
made this file? Have you made?
Yes, ma'am. Ma'am, I have run that program.
Have you run this
And
program? ORI
no,
$T2.
no, ma'am, no, ma'am. The example program one.
No, you run this program.
Okay, ma'am.
Okay. Just create another file, save the file, and run it.
Ma'am, do I need to write that hashtag portion?
Yes, that's nothing but just the comment line. You may omit, but it's always a good practice to write it, right?
Okay, ma'am. Okay, I'm
Yeah.
doing.
Ma'am, that file which you have sent, I also
Yeah. Have you opened it
on
in
my
a notepad? Now you have QtSPIM.
Yes, ma'am.
Yeah.
Yes, ma'am.
Just see
I'm
my
opening it.
screen. I'm also opening it. Okay. So I go to File. Then I click Reinitialize and Load File. Then go to that folder where you have kept your programs and click that program. Now, first of all, you have to see where your program is loaded. Can you see this page? All of you? I will suggest you first, all of you do this program, save it in folder, open it, and let me know. Shorob, are you doing?
Yes, ma'am, I did it. I reinitialized that thing.
Reinitialize, you did it. So what is coming?
Yes, and I pressed the play button, but nothing is
Okay.
happening.
Why? How
Ma'am,
you are saying?
Ma'am,
You are
I'm,
saying nothing is happening? Have you seen the left side?
Yes, ma'am. There are some
No,
red
yes, ma'am.
colors.
In the left side, 000.
Now you click. See, I'll again reinitialize. So reinitialize and load file. I did. See my screen. Okay. Now everything is zero.
Yes, ma'am. This thing happened. The middle portion, the right side, this same thing happened, but the left side, these R5, R6 values, all are 0.
Now you click on the green button.
In fact, I don't even have R thing. It's all like FG. Okay. It's registered.
Ma'am, in
Okay.
right side in
Yes,
my
I got
PC,
it.
there.
Yeah, guys,
Yes, ma'am,
tell
I got
me.
it. R12 value is 4 bit.
Ma'am, I have done.
Yeah. What about?
Yeah, I have also got PC.
Ma'am, in my
So
laptop, they're saying this file does not have an app associated with it for performing when I opened the file from your Google Classroom.
So you can
just
write
open
the
it from your
program.
notepad or Wattpad.
You have to download from there and then save
I am
it.
even if after
in file.
downloading, that is not happening. That's what I'm saying.
Select the app to open the file. There you can select Notepad.
Just a second, I'll just.
But Sankita, can you not
Notepad
create
or
this
Wattpad,
file?
whatever.
Can you not
I
create?
can, ma'am, but I don't know. Like I don't know what some problem is taking place. Like.
Okay, so what
Ma'am,
I'm
can
suggesting?
you show me the program once? That program.
Yeah, here is the program. Here is the program. So all of you, please write this program. I'll be explaining everything in terms of this program first.
Yes, ma'am. Yes, ma'am. I did. I opened the notepad.
So, yeah, who is asking something here? Can
No,
you
ma'am.
repeat?
Again. Yes, ma'am. Like.
Okay, so what I'm saying, all of you open Notepad and copy this text.
Yes, ma'am.
Copied. Now
Yes,
save
ma'am.
it as .asm file.
Yes, ma'am, doing.
Yeah. What about others? Upamita?
Ma'am, I have done.
Shobik, it is done?
Yes, ma'am, I am also done.
Ma'am,
Yes, ma'am.
I'm doing.
Okay.
Ma'am,
from
the notepad, when I go for save it as .asm, there is no as such, like they are not allowing me to save it in any other than .txt.
Can anybody share with the Sankita one of your ASM file so that she can take that ASM file and she can rename it?
Sangeeta, you just download MEMS file and
Yeah, I did that.
put
I
it
did that. I did that.
If
and,
you
and
save
put it in
the
a
same
folder.
file for Google Classroom, that is the same one, that ASM file.
Yeah.
Totally
So you
Yeah,
just
but then
download it and
like if I do it like some other file, like from a notepad, then the txt is not like something else is not happening. That's what I was saying. Like Mammon, I downloaded. It's fine. That one it opened.
So mine one you have downloaded, right?
Yes, ma'am. It opened. It opened.
It opened in QtSPIM. All
Yeah,
of you
and then
can
ma'am
see
in
this screen.
notepad. In notepad, I'll just open.
Not in
QtSPIM.
notepad. You open your QtSPIM now.
Yes, ma'am. Yes, ma'am.
Click on file. Click on reinitialize and load file. Trishita, are you with me? Click on the file you want to open. For me, the name is tested. Whatever name you have given.
Here.
Yes, ma'am. I opened it.
I'm also doing,
now,
ma'am.
Yeah, now you have opened it, right? Okay. Till this point, everybody has done it.
Yes, ma'am.
Okay. Now
Yes,
you
ma'am.
see the first few lines of the code. There is a function called JAL0x004000024. Can you see that?
Yes, ma'am.
What is that? It is a function which says jump and link. That means from where your main start. It is giving the address. It is giving the memory address from where your main start. Which is nothing but 004000024. So here is from where whatever you have written it here, ORI and add, LI, syscall, all these things will start from this memory location 0040024. Till this point, is all of you clear with this or not?
Ma'am, please repeat this part.
Yeah. So what I'm saying is you locate the instruction JL0x004000024. Okay. So this is basically where your instruction main will start. So it is jump and link this address. So PC will be loaded with this address initially. 0x004000024. Agreed? All of you agreed? That is why you go to 004000024. You go here and you see what is the instruction. ORI $10
$10 $0
25, right?
Yes,
now
yes,
you go and check the program. What is there? Here you have $T2, $0 and comma 25. All of you write down in your copy this instruction. All of you. Otherwise you will not understand. Okay? Write it down. The instruction is ORI $T2, $0 and 25. Now come here. Okay. Now you see what it is written here. Just a second, my laptop is having an issue. Just a second. Okay. Now you see what is this? Now this is, write it down again in the bottom of that one. ORI, what is there in 0040024? Write down ORI $10, right? Comma $0, comma 25, right? Now you see, come to the left part and see what is T2.
Ma'am, I have done that program.
You have done that program? Okay,
Yes, ma'am.
fine. Now we will see how it executes.
Ma'am,
Here,
I don't know is it right or wrong. Can I click a picture and send you in the WhatsApp? Can you check that?
yeah, do that. Not a problem. But let me explain this first, huh? Let me explain
Yes,
this
ma'am.
for all of you, and then you can send me everything. Okay?
Okay,
Yeah,
ma'am.
yeah. So just see this. ORI $T2 $0 $25 is getting converted to ORI $10 $0 25. Why? Because T2, the name which you are using there is nothing but R10, register number 10. Okay? I told you if there are 32 registers, then the first address of the first register will be 00000 5 bit. Okay. Similarly, the last register will be 11111. Here, there are some specific registers. I have already discussed about registers in the presentation. So there you can see that T2 is nothing but R10. So that is why you see here the instruction T2 is replaced by $10. Okay. All of you okay with this?
Yes, ma'am.
Okay. See the next line. See the next line. ORI $T3, $0, 50. So you see the next line, ORI $11, $10, 50. So what is $11? $11 is nothing but T3. Okay? Now, can you tell me guys what I am doing here in these two instructions? Or immediate meaning is, what is the meaning of or immediate? Yes? Am I audible?
Yes, ma'am.
Yeah, what is ORI $T2, 0, 25 means?
Ma'am, addition of immediate value.
Okay. Or means what? If you OR 0 with that number, what will be the result?
The number.
The number.
That number.
Right? That means that number, right? That means here we are initializing $T2 with 25. $T2 is the destination register. $0 is one of the operand. $25 is another operand. Okay. So what you are doing? You are ORing 0 with 25. So 25 remains. So $T2 will be initialized with 25. Right?
Yes, ma'am.
Okay. Similarly, I am initializing T3 with 25 again. Oh no, 50, right? T3 is initialized to 50, right?
50.
Yes, ma'am. Yes, ma'am.
Yeah, 50. So now what I am doing? Now I'm adding $T4. In $T4, I am adding $T2 plus $T3. T3 and T2 value is 50 and 25. Total
75, ma'am.
75. Okay. Now
Yes,
let
ma'am.
us execute this program. All of you are with me till this point? How I have
Yes,
mapped
yes,
it?
ma'am.
Okay. So you see the memory location 00400024 is the first instruction, 32-bit. 00400028 is the next instruction. And 4002C is the third instruction. The fourth instruction is ORI this, and the last instruction is syscall.
Ma'am,
Fine.
I could not understand the submission part when you told that add part.
What is add doing? You see, add is doing R4 equals to T4 equals to T2 plus T3?
Yes, ma'am.
So T4 is what? In the left hand side you see this is R12.
R12, yes, ma'am.
So that is why $12 it has taken.
Yes,
Ultimately,
ma'am.
all will be some numbers, right? Encoding
Yes,
after
ma'am.
encoding, you will understand these are all numbers. So T, for our convenience, we are using T4. But T4 is nothing but register 12.
Yes, ma'am.
Got it?
Yes, ma'am.
All of you? Okay. Now let
Yes, ma'am.
me execute it. For execution, you see there is that symbol. Click on that.
Play button. Take it.
Yeah. Now see what has happened. Now the PC value is changed to 400034. Now PC came here, right? Now you see the first value T2. What is 25 in hexadecimal? Number 25 in hexadecimal? You divide by 16 and you get it?
19.
It is 19. Okay? All of you?
Yes, ma'am. Yes, ma'am.
Please
Nineteen.
convert it. Please convert it. Everything will be stored in memory in terms of hexadecimal is used
Yes,
for
ma'am.
your
19.
19. So what is T3? 50. What is 50 in hexadecimal? What is 50 in hexadecimal?
32, ma'am.
32.
Yes. See, T3 is 32 here. All of you can see this.
Yes, ma'am.
Can you see my screen? So
Yes,
you
ma'am.
see here, T2 is 19, T3 is 32. You add 32 plus 19 in hexadecimal, or you add 50 plus 25, that is 75 in decimal, and then convert into hexadecimal. What is 75 in hexadecimal?
48, ma'am.
4B.
4B.
4B, not 40.
Oh, sorry.
4B.
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 Yes, ma'am.
All of you understood this?
Yes, ma'am.
Yes, ma'am.
So just try to understand only this part. Now we will go to the instruction encoding of each one of them. Upamita, are you here? Upamita? She's
Yes,
not
ma'am.
there?
Yes, ma'am.
Yeah, Upamita, have you understood this one?
Yes, ma'am.
Is the same thing happening in your PC?
No, ma'am. That V0
Why?
part has come 8. I don't know why. I'm doing that repeatedly.
Okay. Just do the same thing what I said. So when you reinitialize, you just do this. Reinitialize and load file. And then you load
Yes,
a file.
ma'am.
Okay. Open. You see all are initialized to 0 now. All these things. See the left hand side? Now you run, then the value will get. So I'll just change this value and show you again. So with 50, let me do this with 100. Okay. 100, I save it. I reinitialize and load file, add ticket, and then click on here. So it is now 7D. Okay?
Ma'am, I have a question.
Yeah.
Yes, ma'am.
Ma'am, how to create .asm file? Because in Notepad, Wattpad, there is nothing, not that type of extension .asm.
For all files, when you do, you cannot do it.
Yes, ma'am, there is only .txt extension, not .asm extension. No, nothing there.
No, but I can do it that way here in my.
It will do.
So I'll tell you something. You can do it in this way. Copy this file. You have this file, this test add which I shared.
Yes, ma'am.
Yes, ma'am. Just
You
copy and
just
rewrite
copy
that.
and rename.
Yes, ma'am.
I'm showing you. See, copy and just rename it. Rename it with, let's say, ASS1. Okay?
Okay.
Yes, ma'am.
Right? So say
Yes,
this is
ma'am.
a new file you have created. If you can't do it in this way.
Okay, ma'am. Thank you, ma'am.
Okay. So so is this program clear to one and all?
Yes, ma'am.
Yes,
Okay,
ma'am.
perfect. So let's move to the one that I showed you in the PPT, lab PPT. So the first program which Upamita was saying. Here the concept of word will come into picture. All of you do this. Load address means also, should I explain this program to you first?
Yes, ma'am. Like how to write these programs. Like if you give a question, then how will we write? If you could explain.
First of all, you need to understand these concepts. Okay. So I told you a simple way of initializing two numbers using ORI. So for that matter, you need to know some instructions that are there in MIPS, and then how to write the programs. Right. So let's see this one. So this is a program to add two numbers stored in memory. Okay. And store the result in next memory location. Now the concept of memory location. All of you have gone through the data types that are there in MIPS.
Yes, ma'am.
I have explained that, right? So now you see here the first instruction. The main starts from LA, right? Okay, so before I go here, I have to explain you the instruction encoding, right? For that instruction?
Yes, ma'am.
Yeah. So all of you, let us first understand the instruction encoding, then you start with the programs. Is it all right, all of you?
Yes, ma'am.
Now you see how this instruction encoding is performed. First of all, what kind of instruction is this? So if you go to the PPT, so there is an immediate value here. In this instruction, in this program, if you see, there is an immediate value. What is 25? What is 100? These are some
register values.
These are not register value. $T2 is registered.
Immediate values.
$0 is registered. 25 and 100 is immediate values, right? Register is what? Where you are storing something in the register. Here, where is the register? It is the direct value you are giving in your program.
Yes, ma'am.
When you provide direct values in your program, those are called immediate values. Okay? So, this is a kind of instruction which is basically an immediate value is there. So again, all of you write down the instruction ORI $T2, $0, and 25. Okay. Now we will encode this instruction. Now see this one. This is basically an I-type instruction. In an I-type instruction, please write down the full instruction. Then only you will understand this instruction encoding. The immediate value is 0 to 15 bit. That means 16-bit immediate value. Right?
Ma'am, after writing what, could you explain that part? Like
Which
repeat.
one?
Ma'am, after writing what you told, could you just repeat?
Okay. So this is an I-type instruction. Okay. So you see total is 32-bit, 0 to 31. I'm telling the last 16-bit, least significant 16-bit is the immediate value. Okay. Then the next 5-bit is one of the source register. One RT or RD basically. We will see which one is that one. This one is again another source register which is 21 to 25 bit. And this 6 bit, 25 to 30, 26 to 31, 6 bit here is the opcode. Okay. So let us see how this encoding is happening here. If it is an I-type instruction, you see what is written here. I'm talking about ORI $10, $0, and 25. First of all, tell me what is the immediate value in this instruction.
25.
25 is the immediate value.
Yes,
What is the hexadecimal representation of 25?
19.
19.
19.
It is 19, right? So, so the 16 bit, 0 to 15, total 16 bit will have the value in hexadecimal, right?
19.
We'll have 19. So basically 0, 0, 0, 1, and 9 is 1, 0, 0, 1. Am I right?
Yes, ma'am.
Okay. Fine. Now just see one thing, that what is 10? 10 is, what is 10? 10 is one of the source, 10 is the destination register. Okay. So if you see both ORI, the first 6 bit basically. Okay, the first 6 bit is written 3, 4. So what is the first 6 bit? First 6 bit is 3, and this is 1, 0, 0. So 3, 4. So the opcode for this ORI is basically 0, 0, 1, 1, 0, 1. Because, okay, instead of doing that, first you fill up 0. 0 is, you have filled up 25. So forget everything. First of all, everybody has filled up 25 or not? In 0 to 16, 0 to 15 bit?
Yes, ma'am.
All of you?
Yes, ma'am.
Yeah. Now 0 is one of the source. Okay. 0 is one of the source. So you have to fill up 0 from 21 to 25 bit. See this instruction. See this instruction. So 21 to 25 RS is one of the source. It should be all 0.
Yes, ma'am.
So put all 0 here. Okay. Let me do this. Just a second. So I'm telling you this. I'm trying to encode ORI $10, $0, and 25. As there is an immediate value, this is an I-type instruction. All of you agreed to me that, right? Now I'm trying to encode it. Let's encode it. For encoding, what is the immediate value in this instruction?
25.
25. The immediate value is from 0 to 15. Fine. What is the immediate value in hexadecimal? 25 is 19.
19.
All of you agreed this one? Sorry. Fine. Okay. Now, one of the source operand that is from 21 to 25 is what? 5 bit? 21, 22, 20, 24, 25. 5 bit. One of the source is what? 0 here?
Yes, ma'am.
This is the destination, right? This 10 is the destination. But this is 0, so write 1, 2, 3, 4, 5. Now 16 to 20 is what? Is your destination. What is that? $10. What is $10? What is the value $10?
$1010.
1010. Okay, so I did a mistake here, right? So this is 19, meaning the other 2 bit will be 0000, right? 16 bit, na? This one. So let me write it again. 0 to 6, 0 to 15. Okay, so this 15 bit, how will you represent 19 hexadecimal? This will be 1001 and this will be 0001 and this will be 0000 and this will be 0000, because only these 2 bits will be required to represent 19. For the instruction ORI $10, $0, 25. So 25 I have expressed in 16 bit. Okay, 16 bit hexadecimal. Now 16 to 20 was my destination. Destination is 10, which is 1010. Agreed, all of you? This is another source, 21 to 25, which is 0, all 0. Okay, 5 zeros, sorry. This will be this, this will be this. Now you see how many bits you have encoded? 16 plus 5 is how much? 16 plus 5, 21. 21 plus 5?
26.
Yeah, 21, 22, 20, 24, 25. Up till 25. 24 plus 5, 26. So up till 25, right? Then 26 to 31 will be the opcode. 26 to 31 will be the opcode. Now you see here. Now you go and check this. Here what it is written. Just check. Write it down, guys. 340B, sorry, 340A 0019. Just extend this first, okay? Then we'll map it. Extend this.
We will be writing this in opcode.
Yes, this is the instruction encoding for your MIPS architecture. That is what I'm trying to show you. Okay, so this is the instruction ORI $10, $0, 25, and the encoding of that instruction. Okay, this is the memory location and this is the encoding. In this memory location, this value is stored and the computer takes this value and executes it. What is that? 340A0019. Let me go here and write it down. Then only you will understand it better. Can you see the screen now?
Yes, ma'am.
So now you see 3 4 0A 0019. Okay, let's convert this to hexadecimal. 0011 0100 0000. A is 1010, then 0000 0000. 1 is 0001 and 9 is 1001. First you tell me, this is all right? Conversion from this 8-bit hex code to 32-bit binary?
Yes, ma'am.
Yeah. Now, the instruction that is ORI $10 $025 is an I-type instruction. As this is an I-type instruction, this particular instruction format will be followed. Agreed? For which take the last 16 bit is up till this one. So this is 0 to 15 is the immediate value.
Ma'am, how we can identify this is R type, I type, and J type?
This is the opcode. The opcode will tell. That is why I told you that as the opcode will actually tell that which is what type of instruction. And generally what happens in a computer, basically when an instruction comes, okay, you see there are 3 types of instruction here. R type, I type, and J type. So computer already extracts these bit and stores somewhere. Computer already extracts this bit, this bit, this bit, this bit, this bit, this immediate value. Okay, and this also. All the portions of those things are stored somewhere. Once it reads the full instruction, when it decodes this instruction, then it sees that what is this type based on the opcode. Then if it is R type, then it has to consider this function for its execution. If it is an I type, then it has to take this value for execution, and so on. And
so ma'am, here the opcode will be the first 7, like those 7 digits.
26 to 31 is how many bits?
7 bits.
26, 27, 28, 29, 30, 31. It's
7 bits.
6 bits.
Oh yeah, 6 bits. Sorry, 6 bits. Yes.
Okay, so it is 6 bits. So this is the opcode for your ORI. You see, ORI, this will be fixed.
But ma'am, when we actually calculate it from behind 16 bits and then 4 bit, and then we go for 5 bit, then
no,
in front
you see
this.
So this is how it goes. This is 16.
Yes,
this is 5. This is 5. This is 6. How much?
Oh yes, this is 5. I counted.
Total is how much?
Yes, ma'am, that I made a mistake.
Yeah. Yes. So for your understanding, try to see that how the encoding in real computers takes place. It happens like this. Okay. So as I said, how the computer will understand whether it is R type, I type, or J type, depending on after it gets decoded from its opcode, it will understand. And all the values, all these bit values, this is nothing but some zeros and ones, right? All these are stored in certain registers, such that whenever it understands I type, it will extract this 16 bit and it will do the operation. Okay. Whenever it understands jump type, it will jump to an immediate value which is specified here, and so on and so forth. So as I said, guys, I'll be explaining you in detail the whole architecture in the next semester. For now, for executing, just understand a portion of it. I will suggest that.
Yes, ma'am.
Okay. So let's move on. Now all of you please see this. Have you understood this? Now you see the next instruction. For the next instruction, this is 64. What is this 64? 64 is this immediate value 100. 100 in hexadecimal is 64.
Yes, ma'am.
Yeah. What is $11? $11 is this T3.
B, ma'am.
Yeah.
B3.
So T3, which is R11. So R11 value will be B, of course, in hexadecimal. Okay. And this is 0, this is 1. So you see, you can relate this encoding. Now you see from here, syscall, as I said, is a system call. You see what is the code for that? There is a constant code, 00000C. See, wherever syscall is used, the code is C. 0000C. Clear?
Ma'am, the ORI value is fixed and this is constant 34 because everywhere the ORI will be written, the everywhere will be 34.
Wait, it will not be 34 always. I'll show you with something. Okay. So, okay, don't do that. Okay, let's go here. So his confusion is ORI is always 34. So I'll do this. $T2 is initialized with this. ORI immediate with, let's say, dollar. This one is 0, right? This one is 0. Here we are doing OR immediate with 0, right? Let's say here I do OR immediate with T2. Okay, T2. Okay, T2 has got some value, 25. I'm doing OR immediate with that. Okay, so I saved it. Let me run it. File, reinitialize and load file. I go here, run this. Now see, it has changed, right? ORI?
Yes, ma'am.
Why it has changed?
It is now 35. It is now 35.
Why it is 35?
Because ma'am, the second register value will be changed.
Will change, right? So
yes,
basically, if you see here, the opcode is 6 bit here, but this value has changed now, right? Earlier that value was 0. That's why it was 34. So opcode is the first 6 bit, not 8 bit. Is it okay?
Yes, ma'am.
Yes, ma'am.
Please do it by yourself. Add this one and all others. Okay. So how add is coming like this and so on and so forth. So you will understand. So this instruction, you can do it later. Now I'll just go on. So add R1 comma R2, that one is R type instruction. So R type instruction, these two will be source and this will be destination. Okay, and you will see based on certain opcode there will be a function value. Okay, depending on whether it is add or anything like that. Is that okay?
Pardon, ma'am?
Is that okay? So add, you can do it by yourself. You can do it later.
Yes,
okay, and confirm how it is. Yeah. So now I'll give you 3 programs to do it by yourself. Or if you want me, I can execute one more program. Let's do it this one. Okay.
Ma'am, like, could you just tell, like, how if like questions are given, then how will we write it, like commands and all, like, as we are not used to all these commands.
Okay. So how will you write it means you first need to know the set of instructions that I have given. If I tell you add 2 numbers, add 2 registers having value 20 and 30, you can now do it because or
Yes,
immediate
ma'am.
will be used to initialize, and you can do it that way.
Yes, ma'am.
Okay. So similarly, you have to first learn 2-3 things, and then you can start doing the programs. Okay. So you have seen how we can add 2 registers, isn't it? Now I'll show you the first program, which is .global main. So you know what is a data type. So it's not like int I equals to 0 and all those things. Here we initialize the, so this is dot data. Dot data means this is the data section, and this is the text section. Text section is where you write the text, okay, write the program, and value is where you write the value. Okay, with this program I'll stop, and then I'll give you exercises to do it. Fine?
Yes, ma'am.
Yeah, so see this. In the data section, this is dot word. You can write dot byte. You see the data types. You can write anything. Dot word will be 32-bit. So value colon means value is the starting address of the first one. Okay. So value is the memory location, name of the memory location, where 50 is stored. In the next location, 30 is stored, and in the next location, 0 is stored. Okay. Now what you need to do, you need to add 50 and 30 and store back the result in the next memory location. How will you do that? You think of how will you do that if your data is stored in memory. You have to get the data from memory to processor, right? And then execute it. So first of all, this is an instruction, load address. LA means load address. I have discussed those things in the PPT, right?
Yes, ma'am.
Yes, ma'am.
Yeah. So you have to go through the PPT very nicely to solve this. Load address $T0. So these are the temporary registers that we can use for our program. $T0, I'll load the address of value. Value means the first location will get stored. Then I'll load the word. Word means what is stored in 50. What is stored in that memory location? 50 is stored. So I will load 50 into T1. So this instruction load word will load 50 into $T1. This instruction load word T2 4 plus $. So it is a 32-bit machine. MIPS is a 32-bit machine. So the next location will be plus 4, PC plus 4. Okay. So the next location value will get stored here. Fine. So now I'll add T3 is my destination register, where T1 and T2 is added and stored in T3. And finally, what I have to do, I have to write the value T3 into in the next memory location. What will be the next memory location? If this is 2000, this will be 2004, this will be 2008.
Yes, ma'am.
So 2008 is where you have to store. So 8 bracket T0 means 8 plus T0. 4 bracket T0 means 4 plus T0. 0 bracket T0 means 0 plus T0. Okay.
Yes, ma'am. Ma'am, here as we are using add command, then ma'am, for the previous program, won't we be able to use add command?
What?
Ma'am, like as we are using here the word add as a command to like for the instruction to occur. So in the previous program, won't we be able to write in place of or immediate that add
Add T3 $0 T0, huh? You can write. But you have to initialize a value. How you add 00 then? Okay, you can do that. Just try out with various things. Okay.
Yes, ma'am. Yes, ma'am.
Okay. Let me run this program. Now you see again it started from 24. LUI is this address which is stored. ORI is this address which is stored. Load word, the first word is stored here. The next word is stored here, $0.8, $0.18, $8. That is stored, T0. Okay. And this is executed. Let's run it and see what happens. Okay. You see? After it has got executed, these are the values that came here. How much was there in T3, T1? T1 stores, what is T0? T0 stores the address, right?
Yes, ma'am.
Please see the program. T0 stores the value. Value means what? The address. Address of the first location, that is 50. 50 is the value. Value is stored somewhere in memory. So that location is that one. Okay. Load word is $T1, $0, $T0. Okay. I'm loading the word. Now 50 is loaded in 21. What is 50? 32, which is loaded in 31. Now in T2, 30 is loaded. In T2, 30 is loaded. Okay. What is 30? 30 is 1E. Right?
Yes, ma'am.
And you add 50 plus 30, which is 50. Right? 80. 80.
Yes, ma'am.
80 in hexadecimal is 50.
Yes, ma'am.
Okay. So see, it has executed. So I've shown you two programs, two set of programs. One to add two numbers directly to immediate numbers. Okay. And here it is a set of numbers. So now, if I tell you add 4 numbers, how will you add it? You have to repeatedly do something, because here you do not have an instruction to do that. You can use loop, but we will not be using loop in this semester anymore. Okay. So we will be looking into simple programs.
Okay, ma'am.
So that's all from my side. Now I'll be giving you the exercise to do it. Okay. So should I write it down in the Google Classroom? And that is what you have to do. Compile it and show me the screenshot. This one.
Okay, ma'am.
So how do you do the exercise? It is like this, that you write the programs. What you are writing here, you will be writing in the copy. I'll be giving you 4 programs. Those 4 programs, you will be writing it in the copy, and you will be executing it and showing me the screenshot of execution. The screenshot of execution should be down. Fine?
Okay.
Yeah. So I'm stopping the recording here.
Okay, ma'am.
Yes, ma'am.